When a car turns, especially at high speed, it's important that the frame is properly aligned. Misalignment from an accident can result in an inability to steer. Proper alignment is critical to the safe operation of a vehicle. So today, we're going to see how to align vehicle frames. Check out steering systems and tires and wheels. But before we can do that, we need to know a little bit about the different frame types. Most vehicles are constructed with one of three major frame types: conventional or body-over frame, unibody, and the space frame. In assessing and repairing frame damage, it's important to know the kind of frame the vehicle has and its various parts. Let's start by identifying the major parts of each of these basic frame types. In body-over frame vehicles, the frame provides the structure of the vehicle while the panels are mostly cosmetic. In a unibody vehicle, the body panels are welded or bolted together with the other elements to create the structure of the car. The space frame is a variation of the unibody. It consists of a high-strength steel cage that is covered with plastic or composite panels. These panels typically clip on or are adhesive bonded to the frame. The panels on a space frame can be removed without affecting the structural strength of the vehicle. This is not true for a unibody vehicle where the panels are an integral part of the vehicle's structure. A body-over or conventional frame consists of a front crossmember, side rails, the center section, and the rear crossmember. In a unibody vehicle, the major parts are the header bar, windshield, cowl, strut tower, front rail, hinge pillar, rocker panel, and center pillar. All three frame types can receive 5 kinds of damage. Side sway damage occurs from side impacts. It often causes side bending of the frame or unibody. Side sway can be recognized by buckles on the impact side and a gap on the opposite side. Sag damage is a condition in which a section of the frame is lower than normal. Sag is usually caused by a direct impact in the front or rear of the vehicle and can be detected by a gap between the fender and door that narrows toward the top. Mash damage means that any one section of the car is shorter than factory specifications. Mash is generally limited to the front or rear of a vehicle. Mash can be identified by severe distortion of the bumpers, taillights, quarter panels, floor pan, and trunk lid. Diamond damage occurs when a collision point is in line with the end of one of the side rails. The impact pushes it back, causing the frame or unibody to be pushed out of square. Twist damage is a condition in which one corner of the vehicle is higher than another. Twist can happen when the vehicle hits a curb or median at high speeds. You can recognize twist damage by a low or sagging corner, as if the suspension was broken. When repairing frames, it's important to use control or reference points for making measurements. These reference points are built into the vehicle during assembly. Measurements between reference points for specific make and model vehicles are usually found in a body alignment book, like this. A vehicle is not repaired properly until these measurements are returned to the original dimensions. Once you've carefully measured using the reference points and determined the need for body frame straightening, you can begin the straightening and alignment procedures. The body frame must be aligned first before you can adjust the wheels or suspension. Getting the frame into alignment is not just a matter of using brute force, but a demanding process that combines carefully applied pushes and pulls with frequent measurement. And as mentioned a moment ago, your measurements will need to be checked against the official dimensions for the specific make and model vehicle you're repairing. To straighten a frame, you can either push or pull it back into alignment. Pulling refers to using special equipment to stretch the damaged metal back into place. It's most often done by securing the vehicle to a rack and then attaching clamps and chains to the damaged part. The chains are connected to a hydraulic system that slowly pulls out the damage. Measurements are made until the reference points match the original dimensions. Relatively minor damage calls for only a single pull, where just one chain is attached to the damaged part of the car. In multiple pull operations, several pulling directions and steps are needed. In any pull, it's critical that you don't overpull the vehicle. Overpulled parts may have to be replaced, and that may not have been included on the original estimate. Always remember to carefully measure when you pull. When using alignment equipment, you must follow safety procedures. Serious injury can result from inattention to safety. During a pull, keep these safety procedures in mind. Never allow untrained people to use alignment equipment. Use the equipment correctly and according to the manual. Always anchor the vehicle securely before making a pull and check that the clamps and bolts are tightened. Use the proper size and grade of chain. Never use a service jack for supporting a vehicle. Always use jack stands. Always make sure that rocker panel pinch welds and chassis clamp teeth are tight. During a pull, never stand in a place where a chain might hit you if it snaps. And cover chains with a heavy blanket when appropriate. This will prevent the chain from being thrown across the shop if it breaks. When beginning a pull, remove only the parts that prevent you from getting to an area you need to use for the pull. Avoid removing weld-on parts unless absolutely necessary. When planning a pull, remember that a single hard pull will result in tearing of the metal before straightening occurs. Most work will require multiple pulls to correct the alignment problem. Begin by anchoring the vehicle. This is done with chains and blocking if it's a body-over-frame vehicle. Pinch weld clamps are used for most unibody vehicles. Make sure that the anchoring force is greater than the pulling force. Monitor pinch welds to make sure that they're not straining, buckling, or distorting. Chains are then attached to the vehicle with bolts, clamps, or adapters. Clamps can be attached to any point that can withstand the force of the pull, but clamps should never be attached to mechanical or suspension parts unless those parts are going to be replaced. If there's no place to attach a clamp, you can weld on a pull tab, attach the clamp to the tab, and the chain to the clamp. The other end of the chain is attached to the hydraulic puller. Take all of the slack out of the chain before applying pressure. Corrections and fine-tuning will be needed as you progress with the pull. Remember to pull, measure, pull, and measure. Carefully monitor the pulling process and check your anchoring locations. Once all straightening operations are complete, make final alignment checks. Measurements of all dimensions should be made and checked once more against the body dimension book. Your work can also be referenced to the undamaged side or checked with new or undamaged parts. After frame alignment, fixtures and parts should line up and should not have to be forced or hammered into place. Walk around the vehicle and look for gaps on roof lines and doors. Open and close doors, hood, and trunk. Everything should operate smoothly and easily. With the frame back to factory specifications, you can begin wheel alignment. Wheel alignment involves the final adjustment of the steering and suspension systems. If structural body repairs were made properly, this is a relatively simple task. The basic wheel alignment angles include caster, camber, toe, steering axis inclination, and thrust. Caster is the angle of the steering axis of a wheel from true vertical when viewed from the side. It's a directional stability adjustment and is measured in positive or negative degrees. Caster has little effect on tire wear, but does affect where the tires touch the road. This can be illustrated by an imaginary center line drawn through the spindle support. Positive caster tilts the top of the steering knuckles toward the rear of the vehicle. It aids in keeping the wheels traveling in a straight line. The wheels resist turning and return to the straight ahead position. Negative caster has the opposite effect. It tilts the top of the steering knuckles toward the front of the car and makes the wheels easier to turn. But it also produces less directional stability as the wheels tend to follow the imperfections of the road surface. Caster for each wheel should be equal or the car will tend to steer toward one side. Too much negative caster can also cause the car to have sensitive steering at high speeds. Not a good condition. The most common factor affecting caster is loose bushings around the strut rods and control arms. Caster is not adjustable in most front-wheel drive vehicles, but is built into the frame, so it's important that your frame alignment be true to the manufacturer's specifications. Some suspensions are adjustable and have slotted holes for adjusting caster. If the suspension is not adjustable, kits from manufacturers can be used or shims can be placed on the upper or lower control arm systems. Inserting shims of different thicknesses in the front and the rear of the control arm changes the caster. Camber is the angle or tilt of the wheels inward or outward from the vehicle's center line when viewed from the front of the vehicle. Positive camber means the top of the wheel is tilted out so that the outer edge of the tread contacts the road. Negative camber means the top of the wheel is tilted inward. More of the inner tire tread contacts the road surface. Camber is affected by worn or loose ball joints, control arm bushings, and wheel bearings. Camber is adjustable on most vehicles on some spindle assemblies and is also at the top mounting position of strut suspensions. Cam bolts on the strut will pivot the steering knuckle as needed to adjust camber. Very little adjustment should be required if the strut tower and lower control arms are in their right places. If you find serious camber error, go back and look for or measure for damaged and bent suspension parts. Toe is the difference in the distance between the front and the rear of the left-hand and right-hand wheels. Toe-in is caused when the front of the wheels is set closer in than the rear. With toe-in, the wheels are pigeon-toed or point in at the front. Toe-out is the opposite. The front wheels point out or are farther apart on the front than in the rear. Toe adjustment is critical to tire wear. If properly adjusted, toe makes the wheels roll in the same direction. If toe is out of spec, then one or all of the tires are being dragged sideways, causing rapid tire wear. Rear-wheel drive vehicles are often adjusted to have slight toe-in at the front wheels. This slight toe-in compensates for play in the steering system and suspension action. The tires on rear-wheel drive vehicles tend to toe out while driving, and the small amount of toe-in adjustment will cause them to roll straight. Front-wheel drive vehicles need to have their front wheels set for dead ahead or with very slight toe out. The front wheels can be forced inward by a drivetrain torque on a front-wheel drive car. A very slight toe out will keep them straight while driving. Steering axis inclination, or SAI, is the angle between true vertical and the line through the upper and lower steering pivot points when viewed from the front. SAI is an engineering angle designed to project the weight of the vehicle to the road surface for stability. SAI also helps the steering system return to the straight-ahead position after a turn. SAI will generally indicate damage to the vehicle's structure or certain parts. Using structural measurements and measuring SAI, you can diagnose strut tower misalignment, shifted engine cradle, control arm damage, and misaligned frame or body structure. Thrust angle is the angle between the thrust line and the vehicle center line. A positive thrust angle projects to the right of the vehicle center line when viewed from the top. Negative thrust projects to the left of the vehicle center line. If the thrust angle is between 0 and 3 degrees, the vehicle should not have any tracking problems. To adjust thrust, begin by setting the rear toe equal in reference to the center line. Once the rear toes are aligned with the center line, set the individual fronts in reference to the thrust angle. This assures that the steering wheel will be straight ahead for straight ahead travel. If you set the front toe to the center line but ignore the rear toe angle, a cocked steering wheel may result. It's a steering wheel that's not straight. Setback is a condition in which one front wheel is moved back so that there's an unequal wheelbase between the left and right sides of the vehicle. Setback may be caused by impact to a front wheel assembly that moves a control arm, engine cradle, or suspension rod backwards. Ride height is simply a measurement from a level surface to a predetermined point on the wheel or suspension. If a vehicle is low, it may be an indication of low tire pressure or possibly a broken spring or other suspension problem. Inspecting tires can indicate suspension problems as well. If one side of the tread is worn, it may indicate camber or toe problems. Also, when inspecting or mounting tires, it's important to identify the direction of rotation. Many modern tires are meant to roll only in one direction and have left and right sides. Air pressure is also critical. Tires that are not inflated to the correct pressures will cause steering and handling problems, as well as accelerated or even uneven tire wear. Check the owner's manual for proper tire pressure or look inside the door frame on the driver's door. And there you have it, the basics of vehicle alignment. To recap, there are 5 basic types of frame damage: side sway, sag, diamond, twist, and mash. After careful measurement, major frame alignment can be accomplished on a rack. Remember, safety first. When pulling, take your time. Make sure all chains, clamps, and bolts involved in pulling are properly secured. Most frame straightening will be accomplished in multiple pulls and require measurements and corrections after each pull. Once the reference points on the frames match the original manufacturer specifications, you can align the suspension system. The basic wheel alignment angles include caster, camber, toe, steering axis inclination, and thrust. Checking the wear on tires can point to alignment problems. Once wheel alignment angles or problems have been fixed, the final step is to road test the vehicle. You want to make sure that the vehicle doesn't pull, vibrate, or exhibit any other indications of alignment problems. This is the best part, the satisfaction of a job well done. It's not difficult, and you'll improve with practice, but before long, you'll be aligning vehicles like a pro.